I am Kartik and this is Bhavesh, and here is our project for ES116.
Our project is a rotating servo radar with distance mapping and security alert system. As you can see, this is the radar. So here are the hardware, all the hardware components that we'll be using. We'll be first using a breadboard, an Arduino Uno board. This is the GPIO board containing various sensors, but now we'll be using only the buzzer. And then we'll be using a servo motor, and on top of it, which we have mounted an ultrasonic sensor, which will act as a radar in scanning the area, and we have used few jumper wires.
Hello, my name is Kartik Singh and I am going to explain the working of our circuit. Here we can see that the 5-volt pin of the Arduino is connected to the one line of the breadboard and the ground pin of the Arduino is connected to the other line of the breadboard. Here we have the servo motor mounted with the ultrasonic sensor, and the 5-volt pin of the ultrasonic sensor is connected to the 5-volt pin of the Arduino. The ground pin of the ultrasonic sensor is connected to the ground pin of the Arduino. The trigger pin is connected to the trigger pin, digital 8 pin of the Arduino, and the echo pin with the digital 9 pin of the Arduino. We have our servo motor which the red wire is connected with the 5-volt pin, brown wire is connected with the ground pin, and the orange pin is connected with the digital 11 pin of the Arduino. And here we have GPIO board. Here the 5-volt pin is connected with the 5-volt pin of Arduino, and the signal pin is connected with the digital 7 pin of the Arduino. Trigger pin sends a short 10 microsecond pulse to emit ultrasonic wave. The echo pin goes high for the time it takes the waves to return. And our code converts the time into distance and pairs it with the servo's current angle. If the distance is below 20 centimeters, 7 digital pin turn on the buzzer and alerting us that the object is nearby. Finally, we open the processing IDE link to the Arduino COM and on screen we see the live radar sweeps showing angle, distance, and here the buzzer alerts in the real time.
Now let's look at the processing IDE code which visualizes our radar system. We import libraries for serial communication and connect to the COM port receiving data from the Arduino. The Arduino sends angle and distance, which we read and split using commas and dots. In the draw function, we create a radar-like screen using arcs and lines. We then plot the object based on the distance and angle from the screen. A green line sweeps across the radar like a real radar scanner. We also display angle, distance, and labels on the screen in real time. If an object is detected within 40 cm, it's showed in red on the radar. Otherwise, it shows out of range.
Is used to initialize the servo motor. And let me get you to the main body of the code. So here's the main body, in which the servo motor swipes from left to right, and this rotates servo from 15 degree to 165 degree, as we mentioned in the code. And at each state, moves the servo, its distance, displays angle, and via series. And the buzzer will be turned off or on if the distance is closer than 20 centimeter.
Now let's look at some real world applications of this device. We were curious to know which part of the monitored area sees the most activity. So we tracked how often each angle detects an object over time. What's really interesting is, so we modified the code of the processing ID, and here, as we can see, along with the radar, there is a histogram plotted showing the frequency at which an object is detected at various angles. And between 90 and 150 degrees, we can see a clear cluster indicating something consistently present in that zone. Beyond simple detection, this analysis can drive smart street lighting, lights that activate where movement is heaviest, automotive and robotic obstacle avoidance, intrusion monitoring high security areas, and it can also support analytics, environmental sensing, or any other scenario where understanding spatial pattern in real time matters.